Your first few steps remain the same. Factor out the GCF. What else do I need to factor out if it's there? Put it up. X. What do I have to take care of if it's there? Like I can't leave, negative. I have to factor out -1 if A is negative. That has to happen. You can't leave A negative. Multiply A times C, find factors of A times C whose sum is B. So everything here is exactly the same. So let's go through some of those steps with the first problem. And then once the change happens, we'll start talking about those last few steps. So A is positive, we're good. Can I factor out GCF? No. So now I need A times C. What's A? Question. C. 15. So AC is 30. I need factors of 30 that have a sum of what? 11. Remember, factors of A times C that have a sum of B, which is your middle value. So 11, I heard somebody already say it. 6 and 5. 6 and 5, 5 and 6. All right, here's where it changes. Normally, I would put it into an area model, and just for comparison, I'll do that out to the side. I would put these two as my diagonal, 6x and 5x, right? What would go on my other diagonals? 2x squared and 15, first and the last. And then you would factor from there. When you are solving without the area model, you go straight into your two factors. And you take the two values that you just found, and you're going to put them into your factors. But we know immediately 6 times 5 is not 15, so that's not going to be my last step, right? Yeah. And then I'm going to take my A value. What's my A value? 2. And I'm going to put 2x and 2x. Again, 2x times 2x is not 2x squared. You used one too many 2's. So you have to find a place to divide 2 back out, because we only need 1. So if I look at my two factors, is there anywhere that is divisible by 2? The 2x plus 6, right? So I'm going to divide that one by 2 in order to get my x plus 3 times 2x plus 5. So you basically end up with one too many A values. So you need to factor an extra A value out at the end. Alternately, if I went back and I looked at my area model, you're doing the same thing, you're just doing it within the process, right? Because 2x squared, if I'm looking vertically, 2x squared and 5x, you can't pull a 2 from that, right? What can you pull? Just an x. So that's where you factored out the 2 on the area model. And here, all I can get is a 3. Does that make sense? Yeah. Okay. Let's do another one. Number 3. 8x squared minus 28x minus 16. A is positive, so we're good there. Can I factor out GCF? 4. 4 times 2x squared minus 7x minus 4. Now remember, we talked about this yesterday. If you factor out GCF, you no longer need this original one, because you're going to be factoring the one that's in the parentheses. Also, don't forget at the end that that 4 is sitting out in front. All right, so let's do it. What's A? What's C? So I need factors of -8 that have a sum of what? -7. What two factors of -8 will give me -7? -8 and 1. So you would in your factors, because I'm going to simplify them. So I have my 4. I'm going to put in my -8 and my +1. But for the first part, I need a times x. So 2x and 2x. What do I need to divide back out? A 2, whatever your a value is. So I'm going to divide, which one of these is divisible by 2? -8. So I'm going to divide that whole thing by 2. So my first factor is now just x minus 4. And what's my second factor?
2x plus 1.
2x plus 1. And you're done. Not done. All right, let's look at number 4 together. Number 4. 9r squared minus 5r minus 10. Can I factorize GCF?
No.
Negative. What's a times c?
9.
Negative 90. I need factors of negative 90 that have a sum of what?
-5.
Negative 5. So remember, you can always just list everything. So 90 and 1, 45 and 2, 30 and 3, 15 and 6, and 10 and 9. That's it, right? So if my sum is negative, that means that my larger values are the negative. Are any of those going to work?
No.
No. So if you can't find factors, what does that mean about your quadratic? It's prime. Remember we talked about it yesterday, that doesn't mean that there's no solution. It means that it's prime. It means that it has no real solution. Or, never mind. We'll talk about it later. Pretty good?
Yeah.
Okay. So again, like I told you before, if you hate this and you like the area model, then you can do the area model. But I want you guys to do 2, 5, and 6 on your own. No. Okay, so you factored out the 6 at the beginning. What are my 2 factors on number 2?
A minus 7 and b plus 2.
B minus 7, B plus 2. You don't want me to go through that one, or are we good?
Good.
Okay. Number 5, m squared minus 81. One little trick. M squared minus 81. What is your b value? 0. There's nothing there, right? So if you end up with a scenario like this and you're a little confused, add in the 0 in. That way you can really break down A, B, and C, and you're not making any errors. So when we factor that, what are my 2 factors? M minus plus 9. Good. Number 6, factor out the negative. Then what are my 2 factors?
Negative x plus 4 squared.
Not negative. Oh, yeah. X plus 4 and x plus 4. Or negative x plus 4 squared. If you didn't factor out the negative at the beginning, then you ran into some issues. All right? Make sure if A is negative, you've got to take it out. All right. We're going to factor and solve now. Before it was just expressions, right? X, negative x squared plus x minus 7. That didn't equal anything. Now, I've got x squared minus 12x plus 27 is equal to 0. Make a note, if you are solving quadratics with factoring, or solving quadratic period, you need to have your equation set equal to 0. It has to be set equal to 0. if it's not set equal to 0, that doesn't mean you can't solve it. That means that you need to get it set equal to 0, okay? There are a lot of people jumping straight into telling me that something is prime. Something is not necessarily prime if at first glance you can't figure it out, okay? So it has to be set equal to 0. In the case of number 1, obviously I've got the first one set equal to 0. You're going to factor the trinomial itself. So x squared minus 12x plus 27. My a value is 1. What's a times c? 27. I need factors of 27 that have a sum of what? Negative 12. Negative 9 and negative 3. Very good. Negative 9 and negative 3. So since my a value is 1, I can just throw my factors up because I've got x and x minus 9 minus 3. All you've done is that you've taken that quadratic and you put it in factored form instead of its original. It doesn't change anything. So now it's just equal to 0. Once you have it factored, you're going to take each one of those factors, so x minus 9, and you're going to set it individually equal to 0. So x minus 9 equals 0, and x minus 3 equals 0. And you're going to solve. So add 9, what's my first x? 9, what's my second x? 3. So those are my answers. So we're just adding a step at the end of factoring. Okay? So now we're going to connect it on why it works. I want you to, on your calculator, x squared on the graph, x squared minus 12x plus 27, and graph it. And then tell me what you see. Pull up a graph, type in x squared minus 27, no, minus 12x plus 27, sorry. What does the graph look like? A U. Oh, I think you did times and then okay, it is a U. That U is called a parabola. What I need you guys to do now, push Control T and pull up that table. Now, what's my y-intercept on that? 27. Is that going to fit on my graph? No. What's the first point that fits on my graph? 2, is it 210? 27. Thank you. 27. What's 3? 0. What's 4? Negative 5. What's 5? Negative 8. What's 6? Negative 9. And then it loops back around and hits in the same order those y values. Okay? So I've got this nice parabola here. Is there any connection between that parabola and the answers that you just got? Is there any significance to a 9 and a 3? I heard something about a 0. Who said something about 0? Yuta, what did you say? The y value is 0. They're my x-intercepts. My y value is 0. So my answers from step 2 are my x-intercepts, which are also called zeros. And they're called zeros because the y or the solution is 0. The solution is 0. When we first started on the back of this page, what note did you write at the top? Has to be set equal to 0, because what you're solving for are the x-intercepts, the zeros. So if it's not set equal to 0, you're not finding zeros. And that's what we're trying to find with x-intercepts. All right, let's do some more. Let's look at number 3. Number 3 is already set equal to 0, so you're good there. So if we just start with factoring out 2x squared plus 12x plus 16, what's the first thing I need to do? GCF. What's my GCF? 2. Okay, what would be left after my GCF?
X squared plus 6x plus 8.
Plus 8. So now, we've just made this a little bit easier because now my A value is 1. And when the A value is 1, they go pretty fast. So A times C? 8. Factors of 8 that have a sum of what? 6. Thank you. 4 and 2. So just for the sake of it, I will use the area model. If I have 4x and 2x, let's throw in my A and my C, so x squared and 8. What are the first two values? X. What's the second one on the top? 4. And the second one on the bottom? 2. So my factored form is 2 times x plus 4 times x plus 2 equals 0. So I factored it. I'm down to my last step. Set each one of your factors equal to 0. Now, this 2 has no effect on my x-intercept. So after I factor it out, I'm not worried about it for the solution. So it doesn't need to be multiplied back in. I don't need to worry about it. So x plus 4 equals 0, and x plus 2 equals 0. Then solve those. What'd you get? X equals -4, and x equals -2. And that's it. All right?
We just split them, like,
It works for if it's just x. You have to solve it because eventually, like, we're going to do number 6. If one of them is going to be 3x. So it's going to end up with a prime. Okay, number 6. What's wrong with it? It's equal to 6. It's not equal to 0. Can I make it equal to 0? Yeah. What do I have to do? Subtract 6. So I get 3x squared plus 17x minus 6 is now equal to 0. So if there's something over there, you just have to subtract it over the other side or add it if it's negative. Okay, so from here, we factor. Is there a GCF?
No.
No. All right, there's no GCF, so we jump straight into factoring with A times C. -18. Factors of -18 would have a sum of what? 17. 18 and -1. Okay, so if I'm using my new route, 18 and -1 go into those parentheses with 3x. But I don't want 2 3s, I only want 1, so you have to divide one of them out. Where am I going to divide it from? 18. So divide that factor by 3. So your first factor is x plus 6. The second factor is 3x minus 1. Now we can solve. X plus 6 equals 0. 3x minus 1 equals 0. What's my first x? Negative 6. What's my second one? 1/3. Okay, you guys are going to do number 4 and number 7.